Okay, we're going to take a look now at solving systems by elimination, but now um, both of our equations are going to need to be multiplied by something. So in the last session, we multiplied one equation by some integer in order to get a pair of opposites. And this time, it's not going to be quite that easy. So I can try the same thing. So first of all, I still want to make sure that everything is in the same order, but they are. I have x, y equals some number for both of them. So if anything's not in the same order, just make sure that you rewrite them so that they are. And now I want to take a look at, let's just focus on the x's real quick. I have a negative 3x and a positive 8x. So I usually go to the smaller number, ignoring the sign. So if I look at 3, there's not really an easy way for me to multiply 3 and get 8. Okay, so normally I'd say, okay, well, let me not use the x's then. Let's look at the y's. So then I try the same thing with the y's. So 4 and 7. There's nothing that I can multiply 4 by to get to 7 easily, right? So, last time there was a way to get them a pair of opposites for one of these values. So this time, neither one of them is going to work out. So what do? Well, this just means we're going to have to multiply both equations by something. So what you really want to look for is your least common multiple between two of these. So again, it doesn't matter if you're dealing with the x's or the y's, you pick. In this particular case for number 1, I'm going to pick the x's only because I like that this one's already negative and that one's positive, because I know I'm going to need one positive and one negative, in order to cancel them out. So that one already has one positive, one negative, but it really doesn't matter. You can choose to pick the x's or the y's. I'm going to focus on the x's though, just because of that reason. Sometimes I just look at them, and if one of the variables, if the numbers are too big, I just am like, okay, I'll just use the other one. I'm just using whichever one's going to make my life easiest. Okay, so if we're going to focus on the x's, right? So let's look at these. Okay, so basically what you want to do is you want to find your least common multiple for 3 and 8. So in other words, think about, and here's an easy way to do it, take your larger number, so in this case 8, and think about the multiples of 8. So multiples of 8 would be 8 times 1, which is 8, 8 times 2, 16, 8 times 3, 24, and you're just going to keep going until you hit a number that 3 can divide into. So I start off with 8. 3 does not divide into 8, so that's not going to work. So then I do 8 times 2, and that's 16. Well, 3 does not divide into 16 either. Okay, so 8 times 3 is 24, and 3 does go into 24. So here's what I can do. I'm going to go ahead, and I'm going to try and I'm going to turn this guy into a negative 24 and this guy into a positive 24. So in order to do that, I need to multiply my top equation by a positive 8 and my bottom equation by a positive 3. So just like we did in the last session, when I multiply, everybody gets multiplied by 8. And on the bottom, everybody is going to get multiplied by 3. So I have to do that multiplication out to both, okay? So that's the difference. Last time we didn't have to do that. So let's multiply the 8 through on the top. So that's now a negative 24x plus 32y, 32y equals 48. Okay, make sure you multiply each and every term by 8. Then on the bottom, I do the same thing. That's now a positive 24x plus 21y equals 16 times 3 is 48, negative 48. Okay, and now I'm ready to add these two together because I have that pair of opposites, right? I have the negative 24x and the positive 24x. So they're actually going to cancel each other out. 32y and 21y gets me 53y. And then positive 48 minus 48 just gets me a 0. Again, don't think that you're wrong just because the 0 pops up. 0 divided by 53 is just 0. Okay? So don't think that you're wrong just because there's a 0 somewhere. It happens. All right? So now, just like any of the other ones, once I have one variable, I just have to find the other one. So take either one of your originals. It doesn't matter. I'm going to take the top one, negative 3x plus 4 times, and now I know that y is 0. So I just plug that in. So we get negative 3x, 4 times 0 is just 0. Divide by negative 3. That means x in this case is going to end up being a negative 2. So don't forget to give your answer as an ordered pair, x comma y. Okay, you can check your answer, take negative 2 comma 0, plug it back into either of the original equations. Should work every time. All right, and if it doesn't, something's wrong. Okay, let's go ahead and try the second one. Oops. Okay, so I'm looking at these. I make sure that they're in the same order they are. I'm looking for a pair of opposites. I don't have one. You might get lucky and you might have one. And then I'm just looking, I can either choose to deal with a 4 and a 6, or I can choose to deal with a 3 and a 4. It really doesn't matter. They're both relatively small. This time I'll do the y's just because I did the x's last time. So let's see, if I want to focus on these, so they're already opposite in sign, so that's great. So take your bigger numbers, so in this case 4, and start thinking about the multiples of 4. So 4, 3 doesn't divide into 4, so that's no good. The next multiple of 4 is 8. Can I do 8 divided by 3 nicely? No. Okay, so that's out. But I can do 12, right? So I'm going to go ahead and I will multiply the top by 4 in order to turn that into a 12, right? So I'm going to multiply everything by 4 on my top equation. And then on my bottom equation, I'm going to multiply everything by 3. Okay, so let's go ahead and do that out. So I'm going to do 4 times every single one of these terms. And I'll do 3 times every single one of these terms. And it should work out just fine. So up top, I'm going to get 16x plus 12y equals negative 12. Then on the bottom, negative 18x minus 12y equals 24. Okay, now I'm ready to add these equations together. 16 and a negative 18 is a negative 2x. The y's cancel each other out. Negative 12 and a positive 24 leaves me with a positive 12. And divide by that negative 2. And that is how I end up with a negative 6 for my first value. Okay, and now let's just go ahead and pick one of the originals. I'll just pick the top one. 4 times x is, I know, is negative 6 now, plus 3y equals negative 3. So let's just go ahead and solve. Multiply that through. Add the 24. So 3y is now equal to 21. Divide both sides by 3, and it looks like y is just going to be 7. So my final answer, x comma y, negative 6, 7. Okay, hopefully that makes sense. Let's go ahead and try number 3. Okay, so here I can either deal with a 9 and a 4, which isn't too bad, or I can go ahead and try the 5 and the 8. I'm going to do the 5 and the 8 only because they are already opposite in sign, but again, it really doesn't matter. Oh, maybe I should do one that's not. Oops. Just, oh. Sometimes I hit back too far. Let me just take a peek at number 4 and see. Yeah, okay. I will actually do the X's. Just so you have an example when they are the same sign, how you can handle that. Okay, so if I were to focus on the X's, so let's take 9. 9, I can't do 9 divided by 4. So then I do 9 times 2, that gets me 18. 18, can I divide that by 4? Nope. So I got to keep going. 9 times 3, 27. Nope, doesn't divide by 4. And then 9 times 4 gets me 36. So of course 4 can go into that. So that's going to be my least common multiple. So what I'm going to do, and I want one to be positive and one to be negative. So if I multiplied the top by 4, let's say I did that, that means that that first term would be a negative 36x, which means I'd want the term down here to be a positive 36x. So when I go to multiply my bottom equation, if I want to turn this into a positive, I'm going to have to multiply not by 9, but by negative 9. Right? Do you see that? Do you see why? So let's go ahead and do that out, and hopefully you can you'll be able to visualize it. My equal sign was a little sloppy there, sorry. Okay, so let's go ahead and multiply that 4 through. So that's going to get me negative 36x minus 20y equals negative 20. Don't have a ton of room there. Okay. And then on the bottom, watch how this works out so nicely. If I multiply by a negative 9, negative 9 times negative 4x is now a positive 36x. Okay, see how it's going to cancel now? And then negative 9 times 8 is a negative 72y equals negative 72. Okay, now I can add these equations together and my x's are going to cancel. If you find that after you've done this that it still doesn't cancel, that just means that you didn't multiply by, like for example, down here, maybe you only multiplied by positive 9 instead of negative 9. So then you can just go back and adjust it, okay? You don't have to start all over. So let's look at where we're at. Let me switch colors real quick. The x's are going to cancel. Negative 20 and a negative 72 gets me a negative 92y. And then again, negative 20, negative 72 is a negative 92. So we're going to divide by negative 92 on both sides. And look at how nice that is. That just comes out to be a positive 1. All right, pick either one of your originals. I will pick the bottom one because the numbers are a little bit smaller. So negative 4x plus 8 times 1 is just 8, right? So let's go ahead and subtract 8 from both sides. I get negative 4x equals 0. Divide by negative 4. That means x is just 0. So my answer in this case is 0, 1. Okay, again, do not be nervous if 0 pops up. It happens all the time. Okay, so let's try number 4, last one together. Okay, there we go. So for this one, same thing. I can either deal with 7 and 8, or I can deal with 9 and 6. I'm going to deal with the 9 and 6. And I'm going to, hopefully you'll see why in just a second. So let's start off with 9. I can't do 9 divided by 6. But if I do 9 times 2, I get 18. And can't I do 18 divided by 6? I can. You don't always have to multiply the equations by each other. So in other words, I don't have to multiply the bottom one by 9 and the top one by 6. You can, and you will get a pair of opposites that way. But sometimes there's a much smaller number that you can deal with because I'm just looking for the least common multiple. So there might be one that's smaller than just multiplying the two numbers together. So I'm going to focus on these two, and I want this top one to be a positive 18 and the bottom one to be a negative 18. So what would I multiply the top by to get a positive 18? Just 2, right? So let's get rid of this. I'm going to multiply everything here by 2. And on the bottom, I want this to turn into a negative 18. So I'm just going to multiply it by 3. So that's just a little trick that'll keep my numbers a little bit smaller, a little bit easier to deal with. So let's go ahead and multiply through by that 2. So that's a 14x plus 18y equals 16. And then on the bottom, let's multiply through that 3. That's going to be a negative 24x minus 18y equals a negative 66. Okay, now I'm ready to add these together. Positive 14 minus 24 is going to be a negative 10x. The y's cancel. Positive 16 and a negative 66 leaves me at a negative 50. Divide by that negative 10. And now I get positive 5. Okay, let's take positive 5 and plug it right back in. I'll go right for the top equation. 7 times 5 plus 9y equals 8. So it's going to be 35 plus 9y equals 8. We'll subtract that 35 from both sides. So that's going to get me a negative 27. Divide both sides by 9. And it looks like y is going to end up being a negative 3. Okay, so now I have my x and my y, and I'm done. Okay, so hopefully this isn't too bad. It looks relatively familiar. We're just multiplying both equations by something instead of just one. Okay, let me know if you have any questions.